Hi gang, this is test 1 number 2A. So with analytical limits, the golden rule is to plug in. And you notice if we plug in 0, you get 1/3 minus 1/3 over 0. Or 0 over 0, which is the indeterminate form. And as we discussed in lecture, indeterminate form doesn't necessarily mean DNE. It could mean DNE, but you want to take a moment, you want to take a pause to see if there's a possible technique or way to finesse or modify the analytical limit to see if it does indeed have an answer. So in the case of a complex fraction, the technique we learned in lecture was to use the LCD. So the LCD for this complex fraction is 3x plus 3. So I'll multiply this side by 3. I'll multiply this side by x plus 3 so that they both have the same LCD in the top fraction. Okay, so in the numerator of the top fraction, you have 3 minus, now notice you're going to distribute a -1 through here, so 3 minus x minus 3 over 3 times x plus 3 all over x. So the 3 minus 3 goes away. I'm trying to write out all the steps for you. So this is what's left from the top fraction of the complex fraction, the numerator fraction. Now this means you're dividing by x. So it's this top fraction divided by x, like this. Okay, and we remember from algebra, intermediate algebra, that division can be converted to multiplication. So I would change this to multiplication and I would reciprocate the fraction on the right. So that becomes 1 over x. And then the x and the x reduce. All right, and now since I've completely simplified the complex fraction, I can go ahead and try to take the limit again. So now I will plug in the x value of 0, and I will get -1/9, which is the final answer. So as x, the limit as x goes to 0 on this complex fraction equals to -1/9. That is what the limit approaches. Okay gang, that's it on this one. I'll catch you in another video. Bye-bye.